It's just got to be the worst month by far. It's just because it's like it's almost summer, but it's also like so far away.
Okay. As we finish up with G, we were talking about what happens to slope values as you move from left to right with a fixed y value. This says explain what happens to slope values as you move up from the x-axis with a fixed x value. So up from the x-axis with a fixed x value. So like when x is 1, when x is 2, when x is 3. And of course our brains aren't really in the numbers anymore like they were yesterday. But let's see, what was this? This was -1 and -1/2, -1/3. Over here, and these are all negatives. Over here it would be what? 1, 1/2, 1/3.
Slopes get less steep.
Okay. In terms of less steep, that would mean that they are
Flattening out.
just decreasing, aren't they?
Well, I was thinking because like the one, like if you go on x equals 1, that's negative, and it's getting.
Oh, that's true. Well, how did it read? As you move up from the x-axis, it doesn't specify. And remember, at the x-axis, our slope was undefined, right? Because I'm looking at my answer key. See, dy dx is undefined at the x-axis. They have decreases as you move up, don't they? I guess if we ignore signs, they're all decreasing. But that, and I guess, okay, so in terms of if we ignore whether, these slopes in general are decreasing. Or as you guys said, how do you guys say it? Less steep in terms of that. Okay. So that might be the better way to put it then, I guess, is less steep. So, as I said, mine does mention that dy dx is undefined at x, or at the x-axis. And then otherwise we talked about that they slopes are less steep as you move up. Okay, we got some matching to do. Should have had you guys start thinking about this. So before anyone says anything about answers, okay, no answers, no thoughts out loud yet. Got it? Okay, because what we've got 8 graphs, we've got 8 equations. Okay, we've talked somehow about some of these, how, like, okay, the slope, like their slopes all the way across are the same. And sometimes there's slopes that are up and down, they're all the same. Some places are slopes that don't exist. Okay? So as you start looking at this, try and plug in some key values. Okay? Like maybe plug in something in the 1, 1 area, see what's happening. Plug in something where x is 0 or y is 0. See what's happening. And some of them you'll want to save for last because, okay. One of my hints is if it only has an x in the equation or only a y, okay, you will see consistency in the slopes. Either you'll have vertical lines that are always the same slope or horizontal lines that are the same slope. So that's a good place to start.
Can I say 1 is D?
I have 2 of them. I think. I had 6 as C.
Why would you suggest that 1 is D? Let's start there. Everyone take a look at D for a moment, and everyone take a look at 1.
X can't be negative.
What do we know about square roots? You can only take the square root of a positive value. So what's going to have to be true about x plus 2? X plus 2 is going to have to be positive, greater than 0. And if x plus 2 is greater than 0, then x has to be greater than negative 2. Numbers less than negative 2 aren't going to exist here in the graph, are they? And what do we have here on D? We have places that don't exist, right? And I'm just putting a 1 there as in we've already assigned that to something we don't, But just the fact that on this one, you can't use values less than negative 2. And I know there's no scale on this, but you realize that there's something over here that we can't use, right? Okay, are you guys with Mario on that one then?
Mm-hmm.
No. Mario cannot give another one. Someone else can give one, but Mario cannot give another one right now.
I had the 6 with C because you said the thing about the horizontal lines and Y is on when it appears.
Okay.
It's
So let's see if this is... So 6 is... She's suggesting 6 might be C. With the idea of, okay, so the only value I'm plugging in are Y values, right? So when I plug in 0, for instance, 0 squared plus 1 is going to get me slopes of 1. Okay? I'm just picking numbers, okay? If I plug in, say, 2, okay? 2 squared is 4, plus 1 is 5. We're getting very steep. I don't know where y equals 2 is, but say y equals 2 is right there. Those are very steep, aren't they? Okay? We're getting steeper. Now, I'm not going to assume anything until I throw in a negative value. What happens when I throw in, say, negative 1? It's positive 1 plus 1, which is 2. So say there's negative 1. Could that be positive 2? These are some of the ways I look at it. And you may find things that work for you. But the fact that this one has each horizontal row are y values, right? And each horizontal row has its own, and they seem to be matching up, I would say 6 is probably C. I guess I should probably just check against my answer key. Yeah. So a key thing here is that there was no x. And since there's no x, the y is consistent. Does that make sense? Okay, so since there was no x, my y's are consistent. Okay. Nope. Are you guys with these two though?
Yeah.
Okay. Because I'm trying to give. Because the thing is, I could go through and just say, okay, let's put this one here, this one here. Mario says this one here, But if I don't give you guys a little bit of time to think, you're not getting anything out of it.
It's 4A.
Is 4A. I don't know. What do you guys think? One thing that puts me in the right idea is that this one only has a what in it? An x. So if it only has an x, each of my x columns have to be consistent. Are each of my columns consistent?
Yeah.
Yes, so that's a starting place. Okay. Now, did you plug in some values? What was I on? 4. I've lost my place here for a moment. So cosine of x. Well, I know cosine of 0 What's cosine of 0? 1. What's 0 here?
0.
0. I'm not sure right there. I'm convinced. Do we see why?
Yeah.
Because when I say cosine of 0, I know cosine of 0 should be 1. All of my zeros here have a slope of
Oh,
0.
so then it's 4h.
So, is 4h? Well, first of all, first I'm going to check. Do I have consistent columns where an entire column is the same? Okay. Now, if I start with cosine of 0, if I plug in 0, is cosine 1?
Yeah.
That could be a 1. It's all positive. Okay. If we plug in other things, let's see. Where would we get some zeros? We'd get some zeros at pi over 2 and 3 pi over 2, which easier said than done. Or we can look at pi. The cosine of pi is going to be -1. Well, what am I looking at, h?
Yeah.
Okay, there's 1. It's increasing a little bit. We have some zeros here that might be pi over 2. And then we have some decreasing, which could be your pi, and then maybe some more zeros. And here's the deal. What do you kind of see there? You kind of see the curve. Now, I don't know about you guys, but I know why I think Doug picked A, because it looks like, what's a traditional cosine curve?
Mountain Valley.
It has, which technically is reversed here, but that's the thinking. But keep in mind, this is not a cosine curve, this is the differential. So it's dy dx, so we're thinking derivative here.
So it'd be the sine.
That's how I just started thinking of it, because I was thinking of it all as.
That's how-
Because if you integrate dy dx, you're going to get some variation of sine.
So then.
I think h is 4.
So is that matching up now?
Yeah.
This is really
So then
difficult.
it's a minus.
I get it. It is. You really have to, which is why I didn't want to just go into this of, okay, what do you think? Number 1? Okay, we got number, it takes a little bit of looking. Okay. So we got D, H, and C assigned.
7.
1, 4, and 6. What?
And I believe it's 7b.
7B. Okay. Now, I can't look for the, consistency in terms of a column or a row. So let's see. You said B is what I'm supposed to be looking at? Well, let's see. My columns definitely are not consistent. My rows are not consistent. So this tells me there should be X's and Y's here. Okay. What else did you look at? Okay, if you plug in some values. And here we can kind of look at quadrants. But so, first of all, if I plug in 0 for X, I'm going to get 0, right? If we plug in 0 for Y, you can't really see them. You're going to get 0. Plug in something like 1, 1. Okay? If I plug in 1, 1, I'm going to get a slope of -1. Do I have a negative slope in that first quadrant?
Yeah.
Yeah, the fact that my slope is negative, and is it negative everywhere in that quadrant?
Yeah.
Yeah. What about if I plug in, say, -1, 1? Well, -1 times 1 is a negative, times a negative makes it a positive. Do I have positive slopes here? Yeah. So you can kind of look by a quadrant here. You can look by quadrant. Does it continue and work? We go -1, -1. 2 negatives times this negative here is a negative. Are all these slopes negative?
Mm-hmm.
Yeah, we have negative slopes here. Quadrant 4, all of my slopes are positive. as we get a bigger number out in any of those, so say if you plug in 4, 1, we're getting steeper slopes the farther we get from the origin, aren't we? So can you be convinced that 7 is B? I mean, I haven't found anything to unconvince me. How's that? And hold on. We're taking a moment here. I'm trying to get you guys to give everyone a chance here. And I want to check and make sure I'm on track with my answer key too. Okay, so we've got 4 gone. Doug, what are you going to say?
5 is E. Because I checked it. Because natural log of 1 is 0. If you look at y equals 1, they're all zeros.
Okay. So one thing we notice about 5 only has y's in it, yes? If it only has y's, that means my y rows should be consistent. They are. They're the same all the way across. Okay. One thing that you're supposed to know is the natural log of 1 is 0. So if you do 0 over 1, that's 0. What could this be right here? That could be a 1, couldn't it? Okay. What else is important to realize?
There's no X across.
ln can't be negative.
Okay. Right here, we're saying that because these are empty, our y value must be positive. Natural log of y? You can't do a negative, can you? Okay. So that right there, when you start looking about these, why can y not be negative? We need something where y can't be negative, and that's the only situation we have there. Okay.
I have 8 as F.
8 as F.
This kind of goes along with what we did with H.
With the other cosine curve that we
Yeah.
were looking at. Okay. Now, 8 as F. This is more difficult than the other cosine curve, isn't it? Because we've got X and Y. So one thing I'm going to check, I don't have any consistent, let's see. My columns are definitely not consistent. My rows, definitely not consistent. So I know that this could have X and Y in it. Okay. Cosine, well, at least we know values we can check, right? Is that what you kind of did? I don't know.
I just looked at the pattern of it.
The pattern of it?
How it looks.
Okay. So, what? Cosine of x plus y. So if I start plugging in some values, like, for instance, 0, 0. Notice 0, 0 actually exists, right? Cosine of 0 is 1. So that could be it. If I plug in other things that give you 0, like negative 1 plus 1, negative 2 plus 2. Yes? Think about those. So where would those numbers be? Negative 1 plus 1, negative 2 plus 2, negative 3 plus 3. Are you seeing the diagonal here?
Mm-hmm.
Anything on that y equals negative x diagonal is going to give me a negative 1 slope. It's working. Those diagonals are some hints then. I don't know, what else did you guys do to figure this one out?
That's just about it. I mean,
Just kind of plugging in some pieces.
what does sine look like? I just process of elimination, because then
Excuse me. Is what?
2A.
I don't know.
3 is it.
I have 3A.
3 is it.
Because it's consistent with the Y.
Well, here's the big thing that I'm going to see.
Consistent with X.
3 has x's and y's. 2 only has x's. So if something only has x's, x's are going to be consistent because y can't affect that. What are x's? X's are columns, yes?
Mm-hmm.
And so with that, when I look here, my columns don't stay consistent, do they? Here, my columns stay consistent. So without doing any math whatsoever, based on what I have left, are you guys with me there?
Yeah.
Yep.
I'm going to say for that reason, 2 has to be A. Now, it was process of elimination because I don't know about you guys, but I don't necessarily know what e to negative 0.2 x squared. I don't know that. I don't expect you guys to know that, okay? I mean, yeah, we can talk about what e to the x graph looks like. That's your exponential graph. Here's exponential, right? 2 to the x, e to the x, but when you multiply by x and square it, that all goes out the window. Okay? So that's why I would say 2 is A. Now, hopefully, does 3 and G match up?
Yeah, that's the one I found first.
Okay, and this is where I'd pick some values. So, for instance, if I use 0, 0, sine of 0 is 0 plus 0. So if I pick some things with 0, so sine of 0 plus 1. So that's the ordered pair what? 1, 0. The ordered pair 1, 0 has a slope of 1. Okay, if I do 0 and I say 5, 0. So the ordered pair 5, 0 has a slope of 5. I'm picking some values and putting them in. Okay? Interesting, we get down to 2 and it's a split, a 50-50 split there of... Okay, have you learned something here? They're a challenge, aren't they?
Yeah.
Matching is supposed to be the easy part. But you have to be careful, so. Okay, and the best I can do there is just give you some hints along the way, right? Okay, we got one more and then some thoughts to pull together and we're done. Okay, differential equation, a point and a slope field are given. Use the slope field to sketch a particular solution through the point. Then use integration to find the particular solution of the differential equation. So, I don't know if I really want to draw mine to begin with, but, okay, what kind of things do you see might be happening here?
Is this a natural log graph?
That's what I was thinking. Maybe like an asymptotic too.
Okay.
It's like a curvy absolute value.
Okay. We can think asymptote. And here's the deal, guys. This is our slope field, right? What do we know about this denominator?
X cannot be negative 2.
X cannot be negative 2. If X cannot be negative 2, what's probably going to happen at negative 2? An asymptote. Well, should I really be drawing? Oh, well. I don't know if we really want the asymptote in there or not, but there's an asymptote. Okay. I know. I'm like, okay, that just looks like more slopes, which, you know. But yeah, there is going to be an asymptote. And you know what? That color, I need something that'll actually show up here. That doesn't show up great either, but it shows up better than the navy blue. So we are going to think there is going to be an asymptote in there. I had a question about a natural log graph. In other words, we're kind of, you guys are jumping ahead and looking over there, aren't you, of what we're going to integrate. But what's a natural log graph look like? What I drew on the other page, horrible. Okay, there's an exponential graph, right? Natural log graph is the one that does that. Do we see something like that happening?
Then what is the graph that goes? That's like.
There's
Oh.
two of them?
Yeah, like a point and then it just goes up.
Well, if there's an absolute value in between,
Because
That's
that's
what
what
I was
that's what I thought at first. I was like, oh, so is this one of the?
yeah. And I'll be honest, I don't even have anything drawn over here on the left. I mean, you guys see the idea of, you know, going over, and what is this? This is supposed to go through what, 0, 1?
Yeah.
You know, so you can see how it's going over across there. This is hard to draw with, I kind of missed my point a little bit there, but are you guys thinking of the one that actually connects?
Yeah,
Yeah.
that's the one what graph is that?
So that would be a cube root graph squared. So a cube root graph looks like this, yes? That's a cube root graph. When you square it, it takes the piece here that is below the x-axis
Oh, and it flips it up.
and it flips it up to make it positive.
Okay.
And you get the little bird, right?
Yeah.
Okay? So, but x cannot equal -2. So there's an asymptote here. And as we start looking at integrating, you see the natural log. Okay?
Of course, I didn't look at that. I just looked at the graph. I was like, it was going to be a cube root square.
And, you know, I see where you guys are going with that. Okay, let's look over here. In order to integrate, like what we were doing yesterday, start by separating x's and y's. Excuse me. So that means what's going to happen? Okay. Multiply the dx over, so we have separation of variables. Now we are ready to integrate. The integral of y, or dy, is, man, giving myself away. Integral of 1 over x plus 2.
Ln of x plus 2.
Natural log of absolute value of x plus 2
Plus c.
plus c. Recognizing it is the family of curves there. Now, there's our equation. Okay. Use the integration to find the particular solution. This is not the particular solution. This is your general solution. How do I find particular? Plug in your point. So now, we're going to plug in 0, 1. So what do we know? 1 equals natural log of 0 plus 2 plus c. Okay, so what is c?
1 minus natural log.
I can go with that. C is 1 minus the natural log of 2. We go back and put this together. What is my equation?
Natural log of absolute value of x plus 2 minus.
I'm just going to say plus 1 minus natural log of 2. I think is how I have it written. Yeah. Okay. Other than the fact I kind of missed my point 0, 1 there, you get the idea. Okay. Officially, that's what I should have done. Officially, if you think about it, it would go through this point right here. But that's just knowing a natural log graph. But that's right.
Next
Okay,
example.
next. It's not really an example.
Last one.
Okay. So this is what strategies and trends do you look for when matching slope fields? Okay, so we did all that matching. What were some of the things that we looked at?
Consistency among x.
Okay, so let's see. For instance, if dy dx has x only, okay, and when I say x only, as in x only, not y. What was true there?
It was consistent in all x.
All of those.
Columns, right? X values are columns, which is why I always have to pause and think on this one. Okay, X values are columns, so the way I have it written in here, and I don't know if I like this, slope changes from left to right only. In other words, because it's not changing in the columns. Now, I probably like stating it the other way better, personally. Yeah. How about each column has a set slope? How's that? Trying to put it in words we like.
I don't like words. I mean,
Anyways.
So now let's reverse this. If dy dx has only y's, And you guys are okay with the definition of rows versus columns? You're seniors in high school. We've got that figured out now.
Rows, columns.
I'm just saying. Did you just do that backwards?
No, rows, columns.
No.
That's backwards.
What?
Rows.
Columns are vertical.
Yeah.
Rows
Oh
are
yeah, rows
horizontal.
are on the side.
I don't know which way.
No, I think I did.
Backwards? No. Rows.
Columns.
Each row has a
Rows,
Set.
columns.
slope.
Columns, rows.
So
Columns like
rows,
stand up.
Womp womp.
Think about it, Kylie. You
What are you
columns,
womp womping me? You really can't get it right.
Kylie.
Like
Like
rows
rows
in
in
the
the
auditorium.
Kylie, you row. You don't.
that doesn't help me.
No.
Oh.
Rows. Rows, columns.
Rows are.
Like rows.
Now
you
she's
run
got
a
it.
boat. You run
Yes.
a boat. You're going horizontal.
Okay, I probably should use the word rows and columns.
We all
but-
get it.
I don't like rows.
Well, it's one of those silly things. Like
I love it.
some
Rows.
people have trouble with horizontal versus vertical forever.
Which I just,
Yeah.
I
And-
never had trouble with.
People
So-
yes, you did. Left and right. So.
That one.
Okay. Another comment on here: if dy dx has x and y, then slope is changing in both directions, right? We don't have a constant,
No.
No consistency.
so. Slope changes in both directions. Okay, what are some other things we did? What are some other things we looked for?
What they look like, as in.
Like kind of integrating in your head and what the curve looks like. Okay. When you say,
Y or X greater than 0.
Where it's undefined.
okay, so I would say when you say asymptote, and hold that thought, when we say asymptote, that's looking at where the graph is undefined, or also looking at where we could talk undefined, we can also talk
Does not exist.
zeros. Okay, so one of the things I would say is find where dy dx equals 0 or is undefined. I actually realized I actually have 6 that I put on mine. So talking about where dy dx is 0 or undefined. Did you say something about
Where it's greater than 0.
okay, so positive versus
Negative.
negative. Okay, because especially if you can figure out like, oh, well, this whole area needs to be positive, or this whole side needs to be negative. Okay, so yeah, I have find what conditions will make dy dx less than 0 or greater than 0. So positive and negative, right? dy dx less than 0 or dy dx greater than 0. And then the other one, I don't know if this needs to be one or not that I have, this is kind of my add-on, I think, is just we kind of check specific points throughout, right? Like you at least check a point in each quadrant. You're then, able to kind of say, okay, this quadrant, like there was one where we had, oh, it's a positive quadrant, it's a negative quadrant, so on and so forth. So that was the other one that I had, is just kind of check specific points in each quadrant. Okay.
Only 3 pages of homework.
Now, real quick, so I can stop this.
Is tomorrow the day